Okay, thank you very much, and greetings to wherever you are in the world. Welcome you to our next roundtable. We've been running a few of these last year. We started off with these roundtables with the idea then to allow people from different parts of the data center industry to listen in to some best practice examples and also tie this into the green grid activities and missions. So improving environmental and data center sustainability by tackling water consumption of a facility. This is what we're going to be discussing today, and I'll come to our speakers. First, about the green grid. The mission of the green grid is to drive accountable, effective, resource-efficient end-to-end solutions for ICT ecosystems. Our membership, it's a nonprofit organization, globally active, registered in the US. It's an open industry consortium of end users, policymakers, technology providers, facility architects, and utility companies. So we have quite a mix of different people from different parts of the industry, whether they're from the vendor side, whether they're from the research side, or whether they are from the end user side, and also those who are impacting policy within the data center industry. Our approach is holistic, so we are helping to establish metrics and strategies and best practices for the problems that arise within this industry. We want to drive an understanding of what the risk is, both from a technical aspect, from a business aspect, and from financial aspect. We proactively engage governments to influence effective policy. These discussions take place both in Europe, as they do in the US, Japan, China, and in Singapore. And we provide frameworks for organizations to realize operational efficiency and maturity. Any information you would like to have about the green grid, reach out to us after the call today, or type in www.thegreengrid.org and connect with us. So let me introduce the agenda for today. I'll go through then who the speakers are, who we have today on the call. Then we'll talk about what happened with the development of the WE, talking with Jack Pouchet about that. Then we'll get into the actual site itself, so where this approach has been applied, what happened before, what happened after, what are the benefits and the results. And I encourage you to submit your questions as we go through. I will be following those questions and try to tie them into today's discussion. And if we can't get to your question, I will certainly get to you afterwards. So our speakers today are panelists. I'd like to introduce then top left corner, Ariane Westerhoff. He's a data center manager from a company that's involved in critical infrastructure, Schubeck Phyllis. Then Franz Durieux, founder of a company called Aqua Innovation Network. Then Jack Pouchet, Vice President Marketing from Vertev, also someone we've known for quite a while then from the Green Grid. And myself then today being the moderator running the discussion. So the impact of water consumption in the data center. And Jack, this is where, if I could get you then to open up the line, WE, water usage efficiency. So where did this all begin? So let's talk a little bit about how the water usage efficiency came to be, this KPI. Jack, you were one of the initial authors or editors in producing this paper. So can you talk a little bit where this came from?
Yeah, thanks, Lance. Yeah, it goes back a ways, but early on, after we had developed and launched TUE to the marketplace, and TUE had picked up a lot of traction, we started noticing that some of the environmental and social responsibility organizations were honing in on CO2 emissions, and rightfully so. And, the data center industry was looking at, well, okay, we know we can measure total CO2, but, what does that relate to, right? I mean, how do we relate the amount of useful work related to the amount of CO2 that's produced? And we started working on what became known as CUE, or carbon utilization effectiveness. At the same time, those of us that were working on CUE looked at it and said, well, why should we limit this just to carbon? When we look at data centers, there really are a few things that data centers tend to, and I'm going to use the term consume, but water is really not necessarily consumed. But we looked at it and said, all right, we bring in energy, we turn it into a bunch of ones and zeros, and we bring water in. Some data centers bring water in. We use water to help cool the facility, and we let some water out in one form or another. And so why don't we take a look at the ins and outs of the data center and come up with a metric? And so we took a look at WUE. We took at it, this was an early look. So our first pass was, let's just look at the total amount of water that is basically flowing through the building, however it flows, whether it goes up in evaporation or it goes out through sewer or drainage field or whatever. We just looked at the total amount of water coming into the building and going out of the building. We didn't necessarily look at quality of the water before or after the process. We just looked at the total amount of water and said, okay, we have the beginnings of a metric. We sent that out to the industry, and several organizations that picked it up and are appropriately reporting their CUE for their facilities, their CUE for their facilities, and their WUE for their facilities. So we're quite pleased when we see organizations reporting all three metrics.
We did a search, a market study back a little over a year ago in Europe, and we did see that the WE on the scale of the KPIs comes up not too far in behind where PUE and of course PCIe, same difference, comes in there. So there does seem to be some people that are paying attention to the water usage. Do you see this only in the areas where there is some water issues, or is this? Do you also see in your work that the WE is being applied even where there's an abundance of water, similar to the picture we have here on the screen?
Yeah, well, we're starting to see, Lance, we're seeing more people pick it up. It's not a very difficult metric to use, but PUE clearly has a lot more momentum behind it. But we are seeing organizations begin to take a look at WE and report WUE. May not always be reporting it externally, but we do know from talking to many data center operators that they are looking at WE. They are characterizing it monthly, daily, and certainly on a yearly, annualized basis, which is where it makes the most sense.
Mm-hmm. Let's talk a little bit about the how it's calculated. So we have two units we're talking about, so WE and WE source. If you could just walk us through that.
I was afraid you were going to do that. It's been a while since I've used this one. Yeah, Lance, I'm probably going to goof up the source one because the easy one is just looking at total amount of say water usage comes into the building, and then you're dividing it much like in PUE by the IT equipment energy. So what we're looking at is very simply how much water, whether it's in liters or gallons. Liters is much more universally understood these days. Mm-hmm. But amount of liters per kilowatt. So we keep everything in a standard format, or megaliters per megawatt if you want. It's up to you, but the number comes out to the same. And the goal, of course, is much like CUE and unlike PUE. So here, the goal is to get as close to zero as possible. So I'll speak to CUE for a second. Currently, those that are using 100% renewable energy, around the clock can make a case for, and they're not ever running their diesel generators, they can make a case for having a CUE of 0. The reality is, as soon as you fire up your diesel generator, you have some amount of carbon emissions. So you're close to 0, but not quite 0. Similarly with WE, the goal is to get to 0. Well, gee, if you have chillers and using chilled water systems, which many of us around the world are, it's very hard to get it there, but there's steps that you can do to take a look at driving it down. When we're looking at source water usage and annual site water usage, we're moving further upstream. Now we're taking a look at other components, including the amount of water used in delivering other services to the site, which could be electricity, because there's water consumed or water used in that process as well. So it's looking at a broader ecosystem. It's a little hard to come at that data, and that's why we see people focusing on WUE, because we can look at what comes onto our site. It's much harder to get from the electrical utilities, well, what's the amount of water that's used in deriving and that electricity you're providing us. So again, most people are focusing on just plain what I would call WE sources.
Right.
Harder.
Right. So if I'm focusing on WE, is there an advantage, by the way, for any of the other KPIs? So would this impact some of the other aspects in a positive or a negative fashion?
Lance, and I said, okay, the goal is to get it to 0. Well, yes and no, because there are fine lines to walk in all of this. There are many ways to cool a data center. You can cool it, with mechanical cooling. You can cool it with evaporative cooling. You can cool it with all kinds of means in between, various eco modes of every type of flavor of cooling that's ever existed. And they will have different impacts on the balance of your equations. So if you drive WE to 0, let's just say, and you go with 100% mechanical, the PV is going to go up. And it's not going to be anywhere near 1.1 or 1.2. It's probably going to be around 1.3 to 1.5, depending on where in the world you are. And if you don't use any economy modes, it could be 1.7. So there are factors at play. And of course, for every increase there's in PUE, there's more increase in energy. And depending on the source energy, that could be much more CO2 emissions. So we as an industry and data center operators need to factor all of these things in and decide what level of PUE am I going to drive for, what type of cooling makes sense for my geography, and also for perhaps jurisdictions and legal requirements in certain regions, as well as cost. There's costs associated with each one of these. So there's numerous trade-offs. The goal that we as Green Grid are trying to get people to do is to look at all of them and manage them to their own corporate and philosophical guidelines. And what's the agenda for the organization? What level of responsibility are they striving for? And then to use these tools to manage appropriately.
The last question for you. There is an EU regulation coming out to reduce F-gases over the next coming years up to, I believe, 2027. So would the switch over to water have, would that be advantageous for that? I think it would, because I wouldn't need those gases anymore, from understanding this correctly. And the role of WE would actually increase, or the importance of WE would increase, or what's your take on that?
I think that's a difficult question to answer right now, because it's hard to predict what sort of technologies and solutions are going to come along that can address the gas thing. Again, that's a Europe specific. The people in other parts of the world that don't have to contend with that. So I think each data center operator in each region is going to have to take a look at what the legislation is, what the technology is that's available, what are the best drivers. But let's just assume for now that from a cost perspective and ease of deployment, and meaning you don't have a bunch of bureaucratic red tape and regulations to go through, that water, which is the predominant cooling mechanism around the globe, water remains one of the preferred sources. WUE is today important, and it's going to be even more important in the future, because it is where it's one of the levers that people can use and manage to drive the efficiency of their data center. The water is not going to get less expensive. One of the reasons why we developed WUE is back when we first started this, there were about 1 billion people waking up around the globe every day without access to potable water. That's not changing very quickly. So, it's important for all of us, especially if we're going to build more data centers. That means even if we cut the amount of water in half, if we build 4 times as many data centers, we've doubled the consumption. So we need to take steps as an industry to monitor our consumption and our behavior and take the right steps.
Well, I did reach out to our colleagues then from ISO-IEC Joint Technical Committee 1, Subcommittee 39, and asked, so what's the situation with WE as a KPI? And the response I got back was, it's on the list of things to do, but I think with the development that we're seeing right now in the standardization, which is pushing more towards really clearly defining sustainability issues, not just resource efficiency, but also sustainability, as it is, by the way, coming now into the EN 5600, the Part 99.2. I think we're going to see a need then for these type of KPIs to be defined within, also in the standardization. Would be, I think, be an excellent addition then to the KPIs that are already being implemented or already included in the standardization.
Well, so, we in the Green Grid will certainly help.
That's what I expected. So, well, thanks very much, Jack, on bringing us into the WE, where that is, and giving everybody now a bit of an update on where we're standing with WE. So obviously being used out there. We don't always have access to full information as to the extent in which such a KPI is being used, but where we can make a difference is also bringing it in, as I said before, into international standards, or here in Europe, European standardization. But now let's switch over to Ariane Westerhoff from Schubert Clearlist. We're going to talk to Ariane about an actual project that fits right in to the discussion around WE, the topic around WE, and to bring in all the aspects that we've talked about before with respect to energy efficiency, resource efficiency, sustainability, but also cost efficiency. So, Ariane, here's our picture before the water treatment. Ariane, as we were preparing for this call, you told me a bit of a funny story about something that you were discussing with one of your managers there about the water. Could you tell us what that story was? So I'm assuming, Ariane. So it looks like we've lost somehow then the voice connection here. Okay, looks like we do have a bit of an audio problem. We've lost. Okay, France and Ariane, I can see that audio connection has been disconnected. So if you could reconnect your audio. And while they're doing that, let me then just talk a little bit about what that story was. So as he had told me, there was a discussion with one of the managers wanting to know why there was water being used within the data center. Why does a data center need water? We have a lot of technical equipment in there, running stuff that is really quite sensitive then to water. So why would we have water running in there? And Ariane began then to explain what was going on. And so it became clear then to the management that there is something a little bit more that is going on in a data center. It's not just using space and power, but in this particular case, it's actually using water to help to cool down the data center. So I'm hoping, Ariane, in the meantime, that you're going to be able to join in now. See that there seems to be a bit of a technical problem. Yep. Ariane is working on it. This is the lovely thing then with the technology that we are talking about today to run these data centers, that sometimes we are challenged by some of the most, what we think to be the simplest technology, but it is a very different world today where we're using ICT to communicate to the world, communicate out to everyone. Oh, sorry, we can't hear you. And we seem to have a technical problem here. So my apologies for all the participants. We go through a check about 15 minutes before we get onto the system. Yes, hey. Now we can hear you.
Hey, this is great.
Well, Aaron, I really appreciate it that you've joined us. I thought you were going to leave me there on the hook. Okay.
Absolutely not. We were here, but the thing is, we didn't change anything. Quite strange, and it's working now.
Okay. So.
But I hear also somebody else on this line.
Yes.
I think everybody is off mute now.
Can you hear me? Can everybody hear?
So yes, I can hear you. But if we could ask everybody else who's not talking to mute there, that would be great. Okay, Ariane, let's continue now that we've got you. You ready?
Started with one of the collections. Yeah, we are here.
Okay, good. Okay, all right. So, Ariane, so I started off with the story about how the water was being used, but as time's moving on, could we talk about what we're looking at right now on the slide? So, this was the setup you had before you did anything at all.
Yes, that's correct. Lance, can you hear me now?
Yes, we can hear you.
Okay, great. So let me start with something first. It started with one of the colleagues of Schuberg-Phillips was walking outside of the data center and heard a lot of water draining into the sewer. Yeah, and when hearing this, he asked himself, why are we using such an amount of water for a cooling process, and after that it's going to be wasted? It shouldn't be that way. it's no good, and that's how this started. And it took a while. We've been searching for a better technique than we had before. Yeah, and we came across Frans Durieux from the Aqua Innovation Network. And yeah, when looking to the image, the slides, yeah, that's a schematic of the cooling installation in our data center. And on the right side, you see the water treatment with, yeah, the chemicals and a lot of water to be used. So if you look to the slide, the makeup water was 100%, 50% was going to be evaporated, and 50% was going to be blown down into the sewer.
So what was going to what was happening with this water that was going down into the sewer? I mean, what this so Holland sits on a lot of water. We all know that. So what does that mean then for you as because your data center is near Amsterdam or in Amsterdam? You're sitting on this water. What does that mean for you as an operator with regards to any specific water treatment issues? Or
yes, here in the Netherlands we have a lot of water, but we still have to treat it, to clean it again. So it's not an operational thing for a data center that we throw away such amount of water, but it's not something you want. It's no good, and you still have to pay for the cleaning of the water, and that's a lot of money.
So you're actually you're bringing water into the data center. You're losing half of it in evaporation. You said you're having to pay, of course, for the sewage of that water that's even being evaporated, and at the same time you're having to treat the water before you allow it to go down before it can go into the sewage. Is that correct?
No, that's not treatment. We add chemicals indeed, but there's a difference between the treatments we do ourselves and in the Netherlands. As then it's going back to the water supplier.
Okay. So what are the specific risks then for Holland? So we're assuming that there are specific risks because you're sitting on so much water and you're using that water, not just as data center, but as a society.
To be honest, I don't know. There's no risk coming up for me. Maybe Frans, you can hook on this one.
Yeah, the risks is not so much in the water consumption. So it was a sustainability driver. They didn't want to have a high WUE, to talk in the language of the green grid. They just didn't want to use this amount of water. They didn't want to consume so much chemicals, and they didn't want to discharge water that could be reused in their own facilities. So
what you're saying, guys, is that none of this was known by your management. So this was all new information for them?
Yes.
Okay. So now you had an idea how you wanted to solve it. So how did you sell the idea then to your management that this is what we want to do? I mean, maybe it's clear from what you said before, but were there other concerns that they had? Because there certainly was money that has to be invested.
Yeah, of course. I mean, in the last years, a lot of different type of water treatment installations have passed, but this was a solution with saving water and chemical-free. And yeah, the chemical-free there are two parts. It's chemicals, and it's costing a lot of money. If you look to the ROI, from less than 1.5 years, I mean, that's perfect. So if you do the investment, you get getting return. That's perfect. And further, yeah, the Legionella disease. This system is controlling the quality of water.
Yeah. We'll get down to the results and everything after, but I just wanted to touch in on the point. Did your management immediately then embrace this solution? For them, it was clear that this was a good way to go, or were they not so clear? They needed more inputs, more more tangible information, or was it enough to suffice? Okay, we're going to be able to reduce our chemicals. We'll have a better impact on the environment, or a much lower impact on the environment. Was that already clear enough? Enough motivation for them to do it, or was there something more that you needed to do?
Yeah, to be honest, it took some time, but not only for the management, also for myself, because it sounded too good. We couldn't believe that we were able to reduce such an amount of water and not using chemicals anymore. I mean, why hasn't this used before in the Netherlands? The Netherlands is a country with a lot of water, with a lot of water specialists. So why should we came up with something new and not somebody else came up?
Okay.
So we were also a little bit surprised.
Yeah, too good to be true, huh?
Yeah, that's what we indeed. So it took a little bit of time that we really thought, okay, we really believe in this. This is going to work.
Okay, so let's capture this picture in our mind right now, where we see then with the makeup water, evaporation, blowdown, cooling tower, and where all the scaling was actually happened, so the dotted line around. And Frans, let's move over to how did you, I mean, you're not a data center guy, you're a water guy. How did you get involved in this, or how did that happen?
Well, you're spot on. This is the first data center I ever entered, and almost 25 years in water experience, but this was my first data center.
Okay.
I started my company 3.5 years ago after working for the big ones, the GEs and the Veolias of this world. And ever since I've been looking around for new technologies. They need to be green, they need to be significant, and preferably they need to be proven, because otherwise I don't make a lot of money in the first years. So I found this one on the internet. And I looked at it, and they didn't have a distributor in the Benelux yet. So I reached out to this company, and I fell in love with the technology. I'm a chemical engineer. I'm driven by technology and a passion to make the world a better place. And this ticks all the boxes. It's elegant, it's simple, even I can understand it, which means I should be able to sell it. And so I was in discussion with UET itself, and then suddenly one of the partners of my network contacted me and said, Frans, I now have a client, come on, he's only using 40 cubes a day and he wants to save water. There's nothing that we know of that can do this trick. We can soften the water, but that is only a partial solution. We can put a reverse osmosis unit in front of it, but that doesn't reduce his water consumption at all. So he was in a bit of a pickle, and ended up with calling me saying, Frans, do you have something? And then I said, well, I have something, but it's new. Well, not really new. There are 4,000 of these units globally, but in the Netherlands it wasn't shown before. So I ended up meeting with Arjen for the first time together with his partner, and we just said, okay, this is it. This is what they promised me. I knew about the technology on paper, never seen an installation, never sold an installation, never installed an installation. And so basically my question was, are you the type of client that is willing to use a technology that hasn't been installed in the Netherlands before? And the answer was a big yes. If we can have the proper guarantees, if it is feasible, if it's as good as you say, then we not only can allow a first technology, we would like to be a first mover in this field. And that's how it started off with me. I didn't know if it made sense from an economical, ecological, or any other type of view. I had a client, he gave me the information, and only then we could start with the projection. on the feasibility of this project, which we did, and it ended up beautifully. Less than 2 years payback on paper. So we were really enthusiastic, and then we had to deal with the Arjan factor. His management is the easy part. Going through Arjan is the difficult part. I had to check every piece of our equipment, every piece of his equipment. He put the government on my list of actions to do and to confirm that it's allowed. Man, we had to walk through a lot of hoops before he could finally say, okay, now I'm ready to present it to the board. And 5 minutes later, it was confirmed that this was going to happen. So the management was really a no-brainer after the 9 months of preparation of all the answers on his questions. But the good thing is, I learned so much about data centers. I learned so much about cooling towers, because I'm a water guy, but not a cooling tower guy even. So I learned a tremendous amount of knowledge in those 9 months. And then the installation was easy peasy. The payback was beautiful. Everybody was enthusiastic. I had a good partner that could do the installation for me. And we put it in. We installed it. Well, switching from the one to the other, well, I thought that would be a big deal, and I checked and I rechecked and I triple checked, and it was simply, as soon as you have water in the installation, as soon as you see electrical current flowing, and then basically stop dosing. And that's what we did. We installed the stuff. We saw water coming out of the pipes, so it was full. We put the control box on. We saw current flowing, and then we stopped dosing and started praying. And well, those were interesting times. 2 weeks later, we started with checking the biological performance, because that is the thing that makes me nervous. That's the thing that kept me awake at night. What is coliforms doing, and colony forming units, and what is especially Legionella disease doing with this treatment? Is it really disinfecting enough? Those results were perfect.
So Frans, just in very short term, what is actually this unit doing? I mean, it's treating the water.
Yeah, I didn't explain it yet.
Just to keep it short, what role does it have within the water treatment for the data center? Again, specific just for the data center and for the water that's going into the sewage. Just in very short terms, what does it actually do, and how is it doing it?
Well, you look at the picture, you see green tubes, and those are the reactors. The outside of the tube has a slight positive charge, which means a slight negative charge, slight negative charge, which means that all the positive ions tend to stick to the wall. And most of them are calcium and magnesium, basically the hard minerals that could form scaling inside your system. They are easily attracted to this wall and will form a scaling, because the pH goes up there as well. Which means it ends up like a toothpaste type of substance containing all hard minerals, and the philosophy of that, and that's really nice. Water wants to form a scale if the concentration of certain substances are too high. Normally it will form a scale wherever it sees a surface, but the philosophy of chemical cooling tower treatment is, let's prevent the formation of scale, whereas in this technology it says, okay, it wants to scale, so let's give it a location where it prefers to scale. And that's what we did on this one. Negative charge on the outside, this is the best place, this is the nicest place for the formation of scaling inside a cooling tower system.
So this is what it looks like inside. You took a picture of what it looks like inside of one of these.
Yeah. The first time we opened it, it was a thrilling moment, and this is the actual inside of the first scaled inside of the reactor at Schubert Phyllis. And this is where the scale ends up. It looks like a hard substance, but it isn't. It's a toothpaste-like substance. And we basically screw off the bottom as well, and we scrape it off. And in a couple of minutes, the tube is clean and reinstalled.
So this is all what is not ending up in the system, so to speak.
Exactly. Yeah. Yeah.
Okay.
Yeah.
Okay.
So
yes, go ahead.
There's one more trick. If you can go back one slide. At the top of the green cylinders, you see the bar, the white bar. Those are the connectors with the titanium bar in the middle of that tube, and that has a negative charge, which means the same happens over there. The chlorides go to this bar and form a little bit of chlorine, which is sufficient to keep the bugs dead, and the colony forming units much below what we used to have with biocides. And the last test of 2 weeks ago in Legionella, it was non-detect. So beautiful results with the chlorine that we produce based on the chlorides that are present in the water itself. So we do not add anything, we just treat the water in this reactor, and the scaling doesn't occur anywhere else, and we have production of our own biocide based on the chlorides already available in the water.
Okay, guys, so we've seen that, okay, that how that technology is allowing us to address exactly the two issues: reducing the amount of water that's going to be needed, reducing the chemicals, definitely, because there's no chemicals at all. All the scaling is going away, so we have additional impacts on resources for the data center. So, Varun, perhaps you could talk a little bit about this picture here.
Yeah, well, we can't do anything about the evaporation amount. That's the cooling principle itself. So we evaporate the same amount, but if you look at the blowdown water, you see a minus 90% over there. And as it turns out, we are discharging less than 10% of what we used to discharge before, which means that the makeup water goes down with 40%. So we discharge only less than 10% of the makeup water, which is excellent, nowhere to be seen in the world, on simple, untreated city water as makeup water. What we started off by doing is reduce all the scaling that had been formed in the cooling tower and on the heat exchanger plates already. So not only did we save a lot of water, we actually made the system cleaner than it ever was before. We could see that on the mass balance. We did see a disbalance in the chlorides and the calcium, and it was explained by the fact that we actually cleaned up the system, and currently the system is clean, so we have reduced the power to the system to compensate, otherwise the water would be a bit aggressive. So okay. we can play with it. Yeah.
Okay, so Aaron, did this have any impact on your cooling capacity?
In the end, if we have a more clean cooling tower, it will have impact on the cooling capacity of the cooling tower. But at the moment, I can't say anything about it yet. But it will perform better than it used to do.
Because you told me that one of the things that you've seen after the fact, in fact, you actually ran into a number of positive impacts that you hadn't foreseen. That your maintenance, so the amount of maintenance that you have to do on these systems now has reduced because of this.
Yeah, that's correct. We used to mechanical clean the cooling tower several times a year, but looking back the last few months, we already know that we don't have to clean the cooling towers that many times anymore.
So for those service providers, this is not a good solution.
Yeah.
Okay.
That's correct.
Guys, let's look at the results. I mean, some of it has already been mentioned, but I think this is what some of our callers want to take a look at. I know one of the questions that's come up is I'd like to know if there's any target measures of WE for different data centers. We don't have those numbers, but in preparation of today's presentation, we provided you the information so that you could calculate what your WE is. So reduction 40% we already talked about. Blow down water less, as you dropped by 90%. Your total water cost has gone down then by more than 60%. Interesting, the payback, so return on investment, approximately 1.3 years, but I think that was a more conservative number. And if you could talk then to the concentration factor and how you worked out the WE.
Yeah, so the concentration factor, Frans is going to tell you something about that. That's more the chemical part of water.
Yeah, the concentration factor is the amount of discharge that you have compared to the makeup water. So they used to have, for every 10 cubes of water, they would put 5 cubes an hour to the discharge, and every if you compare it to the current situation, for every 10 cubes, you only have 1 cube an hour going to the discharge. So much higher efficiency, 5 times better than they did before.
And to the WE, how did you work that out then, Ariad?
Yeah, that's the calculation you have seen in the slides before, based per month at the moment. So we have looked at how much kilowatts of IT has been cooled in 1 month compared with the total amount of water being used by the cooling towers. And that's the evaporation and the blow down, of course.
So, I mean, this is an improvement by from where you are today to where you were before. That would have been a factor of 2.8. That's quite a change.
Yes, it is. And the difficult thing was, as already mentioned in one of the questions, that there are not many WUEs available. Not many companies share those numbers yet. So the question is it high, is it low? That's difficult at the moment still. So I really hope that more companies will share their WUE.
Well, one of the comments that I had received, but unfortunately that's not my area of expertise, but that water-cooled chillers were not so popular in Europe. I'm not sure if that it really is the case, but that could be one of the reasons why that number isn't published so much. It could be just for the fact that maybe, as you ran into the very beginning, some people just didn't realize that there is a water usage issue here, and haven't taken steps to go through the same effort of understanding what this could do. And that was all, of course, the point of today's roundtable, to not just talk about the WE as an anomalous KPI that could be used, but to provide our listeners today with an opportunity to see how this could really happen, and also the impact. I mean, if you look at the results that we're looking at here, I think it would take somebody just a few nanoseconds to be able to say, I'm going to do this or not, especially when we see that after the investment, after 1.5 years, everything I'm investing there has not only been recovered, but it's going to further impact also the operational costs because of some of the things that we noted with reduced maintenance. Were your expectations met?
We didn't expect this. We expected, we calculated something about 80%, and we thought that's really high. We couldn't believe that, but yeah, we found out that it was higher than the 80% we calculated. It's more than 90%. So we are very happy with that.
So your expectations were actually exceeded, and I think that's one of the
Absolutely.
things that came out in our initial discussions, that you were surprised yourself how good this was going to turn out.
But also the fact that you don't need to use chemicals anymore, and that's really something we like. And next to that, the installation is what Frans already mentioned. Is so simple. We know it's working, and we almost don't have to look after the installation. So that saves also some time every day, every week. It's running very well. So it's not only about water saving, chemical saving, financial saving. We know on the operational side that we are in control, and that's something we like.
Okay. Well, gentlemen, we're coming up to the top of the hour. I'd like to summarize then on today's call. We've looked at what was the initial use then of the how the WE actually came into life. We see that the WE is being used, but not standing so much in the forefront there. Looking at today's example that Erin and Frans have explained, obviously something's going to be quite interesting for, I know someone who's on our call today who's involved very much in sustainability. They're going to be certainly interested in taking a look at this. And I'm hoping that everybody who had the chance and opportunity to sit in today saw that, yes, these KPIs for resource efficiency and for sustainability are reachable. They're reachable goals. And it's, I think all of us on representing today, we're all following the same line that we would like to see that the society that we leave behind for our children and for their children is going to be a much more sustainable one. So thank you to all the speakers for today for all your preparations, and any of the questions that had come in or comments that had come in that we weren't able to address within this hour, we'll certainly get back to you. Again, thanks then from the Green Grid, and wish you all, wherever you are, fantastic and very successful day. Thank you very much.